Hi everyone, today we're talking about how to solve surface area word problems. As a reminder, you do not need to write down everything that we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. Just be careful, make sure you don't miss out on something important. So when we're talking about surface area word problems, that means that they're going to give us a situation in the word problem, and we have to figure out when we're talking about surface area or if we're talking about volume. And those two are very similar but also very different. Today we're just looking at surface area. So remember that surface area is when you have any type of material that wraps around a 3D shape. So the key word is surface. If it goes around the surface of the shape, then we're talking about surface area that you need to find. So paint can go around the surface of a shape. Obviously, paint can go inside a shape too, but if you're painting something, you're not filling up something with paint, you're wrapping it around something with paint. Cardboard is also something that can wrap around a 3D shape. So if I'm making a cardboard box, I need to figure out how much cardboard I need. Wrapping paper obviously wraps around a 3D shape. I need to find the right amount of wrapping paper so I can cover the 3D surface. Carpet is going to be used for wrapping around a 3D shape. And obviously fencing as well. That's going to go around something as a barrier. Okay? So make sure that you've jotted down these important examples because they're really going to help you with your word problems today. Also, if you have your surface area formulas handy, make sure that you have that as well for you to look at in case you forgot how to solve surface area. Okay, let's look at a couple of examples then. This problem says that Shanti wraps the gift she is taking to a friend's birthday party. She doesn't have very much paper, so she does not overlap any of these edges. Like, she only has just enough paper to cover the sides. We've all been there before. You're at the end of the wrapping paper roll, and you're like, I just need to cover up the actual box so that my friend doesn't know what's inside. I don't need all the fancy extra stuff to wrap around it. I just need to cover up the faces. So she's going to need to do some math here. How much paper did it take to cover the gift? Go ahead and pause the video and try it on your own first. Okay, so it looks like since they just gave us 5 inches that we can assume that everything else is also 5 inches. Okay, and we're talking about surface area. So that means that we need to unravel this into a net. So I'm going to start with the bottom. The bottom, if we open up this box, it's going to open up all these sides. So this is the side, this can be the front, this is the back. Okay, so we have the front going up, the back going up, the sides both going up. And then that means we're just missing the top. So I can put the top right here. Okay, so I'm just labeling all the faces like we did before to make sure I didn't miss any of them. I can also verify it over here. I have the bottom and the top, that's 2, front and the back, that's 4, and then the 2 sides, that's 6. So I should have 6 total. 1, 2, 3, 4, 5, 6. And we notice that all the sides are the same. So 5 by 5, 5 by 5, 5, 5, 5, 5, so many 5s. But we know that there's 6 of them total. So there's really 6 of these squares. And each of these squares are 5 by 5. So we can take the 5 by 5, that's the length times the width for each of these squares. And we could either add that up 6 times, Or we could just take that length times that width and multiply it by 6, because we're going to do that 6 times. Okay, that's probably better. So the length and the width are both 5. So it's 6 times 5 times 5. So it's 6 times 25. 6 times 25 is like having 6 quarters. Six quarters. I know 4 quarters give me $1, and then 2 quarters give me 50 cents. So it's $1.50. So it's 150. So our answer is 150, and then this length and this width had inches. So it's 5 inches times 5 inches. So that's going to give us inches squared, because there's only 2 dimensions here, length and width. So this answer is 150 inches squared. That's how much wrapping paper she needed. 150 inches squared. Now, if she didn't have that much, then she's kind of out of luck, but usually by the end you have at least that much. Hopefully you got that answer correct. We're going to do one more. This problem says, at an ice carving competition, each carver starts with a block of ice with the dimensions shown. So they're going to each have a block of ice, and then they're going to chip away at it to create their creation. The block is wrapped in a special reflective material to keep it from melting before the competition starts. That's very smart, or else if you just keep it out there, it's going to melt, right? So all the things they have to think about. How much reflective material is needed to cover the block completely without any overlaps? So again, just like the present problem, we're looking for how much they're going to cover the surface. So we're looking for surface area. And in order to do that, we're going to need to figure out the net. So this is not as perfect as the other one. This is a rectangular prism. So I'm going to need to draw out what this looks like. This is the bottom. Then we're going to have the sides. Sides look like a little shorter. There's only 3. It's not going to be perfect. And then the back and the front. And then let's see. So this is the bottom, this is the back, this is the front, and then these are the 2 sides. So all we're missing is the top. The top can go over here and just fold over. It really doesn't matter. It could have gone here, could have gone here, could have gone there. It doesn't really matter, as long as it does fold over at the end. And then let me put in my numbers so that I can see this. So the bottom was 4 by 2. So that means all these are now 4s to make my life easier. And then all these are 2s. And then we just have to fill in the 3s. The 3 is on this side here. If that's a 3, this is a 3. So remember that these 2 have to match up later. This is going to get folded up, and so is this. So they're both going to be 3s. 3 and 3. Let's see, what is the top? Well, the top, it's missing this number, but it's going to have to match the bottom. So these are 2s. So it's important to know which ones match together if you're ever confused. But basically, if they're parallel, like going in the same direction, they're going to have the same number, just like these 4s and these 2s. So now we're going to figure out the surface area. This one's a little trickier because all your faces are a little different. But you do have the bottom and the top that match up, so 2 of those. 2 that have the 4 by 2. Plus, you have 2 of the sides. Your sides are all 2 by 3. Let me make that a little clearer so it doesn't look like another 2. And then you have, so we had the bottom and the top. We had the sides, so now we just need the front and the back. There are also 2 that are matching. So let's see, the front and the back. We're missing the 4 by 3. Okay, so when we're figuring out this stuff, we're going to do 2 times the length by the width, so that's 4 times 2, plus 2, the pair of the 2 times 3, plus 2 of the pair of 4 times 3. So these are all going to be doubled. That's why at the end I multiply by 2. So this is 2 times 8, because this length times width is 8, plus 2 times 6, because their length times width was 2 times 3, and this is 2 times 12, because 4 times 3, the length times width is 12. And remember at the end we're multiplying each of these length times width by 2 because they each have a pair. This bottom is paired up with the top, if you want to color code it. This side is paired up with this side, and then this front is paired up with this back. So each of them multiply by 2. Okay? All right. So 2 times 8 is 16, and that was 4 feet by 2 feet, so this is going to be 16 feet squared. This is 2 times 6, which is 12. That was 2 feet by 3 feet, so this is 12 feet squared. This is 24. It was 4 feet multiplied by 3 feet, so it's 24 feet squared. After we add them all up, we're going to get the surface area, the total surface area. All those surfaces areas need to be added up for the entire thing, which looks like is 52 feet squared. So that's going to be how much of that reflective material they're going to need. They want to reflect the sun's rays away so that it doesn't melt. Okay, so all these problems should relate to surface area, how much surface you need. So you do need to go back, remember how to make your nets, add up all the surfaces, remember to keep track. Most of the time there's going to be pairs. It really does help to color code and label so that you know if you're missing anything or if you mislabeled something. Okay? Let me know if you have any questions as you work on these, and I'll see you in class.